So we are doing the 2012 released free response question, section 2, part B. We're doing problem number 3. This is a no calculator problem, so we're going to have to use our wits on this one. They give us a graph. Whenever they give us a graph, the most critical thing we need to look at is this a graph of f, f prime, or f double prime? Or maybe it's the graph of the integral of f. So we look here and it says the graph of f. That's the first thing we should be aware of. This is the function f, it's not the derivative. All right? Now it says let f be continuous, be the continuous function defined on the closed interval -4 to 3, whose graph consisting of 3 line segments and a semicircle centered at the origin is given above. Let g be the function given by g of x equals integral from 1 to x of f of t dt. A couple of things we want to notice right away. Since they took the time to tell us that the graph consists of 3 line segments and a semicircle, that means we get to assume that these are straight. This is a circle, so I can find its area by pi r squared. It's also a hint to us that since all of the shapes are geometric shapes, they're triangles, trapezoids, and circles. So if I draw down to the x-axis, I've got a nice trapezoid here. So this all breaks up into geometric segments. That's a hint to us that we're probably going to need to find the area under this curve at some point. And find it by geometry. So now they give us this function. Now look, the graph is a graph of f, but the functions are all about a different function, g, and that graph g is the integral of f. So the questions are about g, but the graph is about f. That's another important thing to notice. So now it asks us to find the values of g of 2 and g of -2. And of course, we're not just going to go on here and say, oh, here's -2, so g of 2 is 3. G of -2 is 3. It's not going to be that simple because this is asking about g, this graph is f. Now it asks us for each of g prime of -3 and g double prime of -3, find the value or state that it does not exist. So these are derivatives, and possibly, you know, we see a corner here, maybe somehow there's a derivative that doesn't exist. Part C is find the x-coordinate of each point where the graph of g has a horizontal tangent line. So we want to think about what horizontal tangent line means. It means that the graph of the function, the graph of the derivative of the function is 0, has an x-intercept. For each of these points, determine whether g has a relative minimum, relative maximum, or neither a minimum nor a maximum at the point, and justify. So because we're asked for relative minimum and relative maximum, we need to think what happens to the graph. So we're not given a function. Everything has to come off the graph. So we have to know what happens to the graph of the function when it has a relative minimum, relative maximum. It's not going to be as simple as saying this is the relative minimum, this is the relative maximum. We're going to have to know what happens, for example, to f prime. At a relative minimum, f prime changes from negative to positive. At a relative maximum, f prime changes from positive to negative. We need to know those are the kind of things we should see them looking for. And then for x between -4 and 3, and for some reason they've given us an open interval here because we don't have equal to. So for x in this open interval, find all values of x for which the graph of g has a point of inflection. So we have to think what point of inflection means. Point of inflection means the graph is changing concavity. And we need to explain our reasoning. So if we note in part A and part B, they don't ask us for any justification or explanation. So in A and B, we're going to show our work, but our answer is just an answer. Whereas part C, we have to justify and we have to explain. So we're going to need to do some writing there. So that's our question, and let's formulate our strategy and get started.